Hello dear students, I am Abhijeet, your physics lecturer, and today we are going to start a new chapter, that is electric charges and fields. Now this electric charges and fields comes under a very big theory in physics which is known as electromagnetism. Now this is quite a big theory, and this theory is again subdivided into two parts. The first one is electrostatics and another one is electrodynamics. Now, this electric charges and fields comes under the section of electrostatics. Now, electrostatics is a branch of physics that deals with the charges at rest, whereas electrodynamics is a branch of physics that deals with the charges in motion. Now you can differentiate between both. Both are dealing with charges. The only difference is here it is dealing with charges at rest and here charges in motion. We'll come back to the charges. What are the charges? What are the properties associated with the charges and other phenomena? Now in this electrostatics, you are going to study a concept of electric field, electric force, what is Gauss law, capacitors, electric potential, and so on. In electrodynamics, you are going to study four important chapters. That is current, electricity, moving charges and magnetism, magnetism and matter, and alternating current. Then further, this is part 1 of your syllabus. In part 2, you are going to study about optics. Optics basically deals with the light. Now you know that light undergoes two important nature. First one is a ray nature and another one is wave nature. So in optics you are going to study the ray nature of a light and also wave nature. In the ray nature you are going to study a phenomena like reflection, refraction, Snell's law, total interreflection, optical fibers, and so on. Angle of minimum deviation, how does the dispersion takes place. And in wave you are going to study a phenomenon like interference, what is polarization, what is diffraction, and so on. The last part of your syllabus is modern physics, which is a part of a quantum mechanics. Now modern physics covers four important chapters. The first one is dual nature of matter, or you can say radiation, atoms, nuclei, and electromagnetic wave. Okay, in this you are also going to study about the semiconductors. So this is a brief introduction of the syllabus allotted to you in second year physics, PUC physics syllabus. Okay, so let us not waste your time and we'll directly begin with our first chapter, that is electric charges and fields. Okay. Now electric charges and fields. Now what is meaning of charge? What is a charge? Can anybody tell me what is a charge? Now charge is an intrinsic property of a matter. Charge is an intrinsic property of a matter. Now what is meaning of an intrinsic? It is a fundamental property, or you can say it is the basic property. Okay, charge is an intrinsic property of a matter. Now what is a matter? Anything which occupies space and has a mass is known as matter, right? Now matter, how does the matter is formed? You know that any matter is because of the atoms present within it. Two or more atoms will combine and form one element, right? Correct. Two or more elements will compromise and together form what? Compounds. Two or more compounds will form what? One matter. Okay. So from where did it all started? Matter, it started from atoms. So atoms will form what? Molecules. Molecules will give rise to elements like hydrogen, helium, lithium, and elements will give rise to compounds like H2O is one compound, CH3Cl is one compound, NaCl is one compound. So two or more elements will form one compound, and many compounds together they will compromise and form one matter. Now it all started with what? From atoms. Now you know that in your earlier classes you have studied about the atoms. Now atom consists of three important fundamental particles. So if you take any atom, it is made up of three fundamental particles. The first one is electron, proton and neutron. Correct? So you know that this electron is a negatively charged particle, proton is a positively charged particle, whereas neutron has no charge, or you can say the charge of a neutron is 0. Now when I say electron, proton, these are called as what? Charges. Okay, so charge is an intrinsic, or I would say it is a fundamental, or it is a basic property of any matter. Okay, so will you remember this definition? What is a charge? Charge is an intrinsic property of a matter. Correct. Now charge is denoted by a capital letter Q. It is denoted by capital letter Q. Q is equal to plus or minus Ne, where E is equal to charge of an electron, that is 1.6 into 10 to the power minus 19 coulombs, and N is integer. It can be 1, 2, 3 and so on. Okay, so charge is denoted by capital letter Q. SI unit of charge is coulomb. SI unit of charge is coulomb. Okay, always represent SI unit in capital letter Q, because coulomb was the name of the scientist. So SI unit of charge is coulomb. Charge is a scalar quantity. Charge is a scalar quantity. So it has a magnitude, but it does not have any particular direction. So my charge is always a scalar quantity. Remember, there exist two kinds of charges: positive charge and negative charge. So there exist two charges: positive charge and negative charge. So before we go to the positive and negative charge, you have to know that in general any matter will be in neutral state. Now why? Because any matter is made up of atom. Right now we have seen that. So an atom consists of what? Protons and electrons, along with that neutrons. So proton is a positively charged, whereas electron is a negatively charged. So in any atom, it is always found that number of protons are always equal to number of electrons. So when number of protons are always equal to number of electrons, so the net charge of an atom becomes what? 0. So in general, any matter will be electrically neutral. So in any matter you will find two kinds of charges: a positive charge and negative charge. So there exist two kinds of charges: positive charge and negative charges. Remember, always like charge will undergo repulsion, or they will always repel. Like charge will always repel from each other. So if I take an electron with another electron, and if I try to bring them closer, they will undergo repulsion. Okay, so like charges will always repel, and unlike charges always undergo attraction. They always undergo attraction. Okay, so this is the basic introduction of the charge. So what is a charge? It's an intrinsic property of a matter, or it is a fundamental property. It is denoted by capital letter Q. How you measure it? Plus or minus Ne, where Ne is the charge of an electron, or you can say proton, because this is the smallest possible charge that you can add or remove. Okay, so SI unit of charge is coulomb. Remember, charge is always a scalar quantity. There exist two kinds of charges: positive charge and negative charge. Okay, like charge will always repel with each other, and unlike charges will always attract with each other. Have you copied this? Okay. So we'll go further to the properties of the charges. Properties of the charges. One by one we are going to study the properties of the charges. Now the first property is electrical charge, I'll tell you why I'm writing the word electrical. Electrical charges are additive in nature. Electric charges are additive in nature. Now, why the word electrical? Now see here, you know that, this topic is basically a application of the electricity, right? And you know the applications of the electricity. Like, you cannot imagine your life without electricity, right? The televisions, the mobiles, the laptops, whatever, the camera right now what we are shooting, it is because of the electricity. So it's very difficult to imagine a life without electricity. And from where we are getting this electricity? From the electrons. Okay, and where does these electrons are found? An electron itself is a charge, and they are found within the atom, right? Now the question is, why we are giving more stress to the electron? Why not to the proton? See here, if you know the atomic structure, at the center I have a nucleus, and around the nucleus there are orbits, right? This is what you have studied in the atomic structure. And nucleus is very small particle, okay, and within the nucleus I find protons and neutrons, right? And around the nucleus I will find lot many electrons, correct? Now, why the preference is given only to the electrons? Why not the protons? Is it not proton is not having a charge? Why I tell electrical charge? Why I don't call protonic charge or something like that? Why we study electronics? Why we don't study something like protonics? Quite weird, but we have to know the reason behind this. Now, these electrons are mobile in nature, or these electrons are loosely bounded towards the nucleus. Whereas if I take the proton, protons are held within the nucleus. There is a strong nuclear force which is holding the protons together. So it doesn't mean to say that proton will not give me the current. I can also generate the current from the proton, but it is not convenient for me to take the proton from the nucleus, because I need to spend more energy, and that more energy may result into any kind of disaster, because indirectly I am doing nuclear fission and fusion reaction. So taking the proton and giving him certain energy and making him move and generating charge from it, electric current, is very difficult. But electrons I can prefer. So electrons are mobile in nature. Now the question is, which electrons are to be preferred? Now you know that this you can imagine this like a mini solar system, where sun is at the center and other planets are revolving around this, correct? And sun and planets will have gravitational force of attraction within them. So you know that the planets which are very far away will experience a less force, because force vector is inversely proportional to the square of the distance, right? Now if I say this is electron 1, this is electron 2, this is electron 3, and this is the fourth one. So which one will be convenient for me to generate the current? Which one will be easier? Obviously the fourth one, because the distance is more, and if the distance is more, the electrostatic force of attraction will be less. So I can easily use little bit of energy and make this electron move. So the electrons which are present in the outermost shell of an orbit or outermost shell of an atom are always preferred to generate the current, and these are called as valence electrons, or I would call it as free electrons. Okay, so we are giving more focus on electron rather than any other charged particle. So it is very difficult to spend energy on the proton. Okay, so the first property is electrical. Have you understood why the word electrical? So electric charges are additive in nature. So what does it mean? So see here, electric charge you can either add or you can remove. Now see here, if I take a rod and rub it with a silk, so what will happen when I rub a rod with a silk? See here, initially the rod is electrically neutral as well as the silk is electrically neutral. But when I rub a rod with a silk, what I am doing? I am electrifying both of them. Yes or no? This method is frictional method. Okay, there are methods to electrify, we'll see it later. But when I rub a rod with a silk, what will happen? The exchange of ions will take place, or the exchange of charges will take place. So here what happens? Iron is going to lose the electron, whereas silk is going to gain those electrons, right? So when I take a iron rod, so initially they are neutral, and when I take a silk cloth or rub it, both are neutral. But when I rub with each other, iron is going to lose the electron to the silk, which is negative. Yes or no? And the silk is going to gain the electron, right? So what you are doing, you are giving the charge to the silk cloth. So what will be the nature of this? The iron has lost the electron, means what? The protons has outcome the electrons. So automatically the charge of a rod becomes positive, and since it has already gained excess of electron, the charge of a silk cloth will become what? Negative. So this way you can either add or remove the charges. Okay. So electric charges are additive in nature. So in an isolated system, the vector sum of the electrical charge of a system is equal to the sum of the individual charges of a body. Now suppose there is one body whose net charge is 10 microcoulomb. Just an example. Okay. So net charges. So when I rub this body, okay, so what will happen? Some electron 2 microcoulomb may go here, 5 microcoulomb may again exchange to the other. But when I add these all charges, the vector sum of all the individual charges will be equal to the sum of the charges of the isolated system. Okay. So electric charges are always additive in nature. Electric charges are always additive in nature. Second important property is electrical charges are always quantized. Electrical charges are quantized. Q equals to plus or minus Ne. Now electrical charges are quantized. What does it mean? So let us understand by one simple example. If I ask you the question, is your food quantized? Do you take specific amount of food every day? If you tell that every day I eat one chapati only, tomorrow also same one chapati, day after tomorrow same diameter, same radius, no, not possible. So our food is not quantized, but the charge of an electron is always quantized. What does it mean? It has specific amount of energy. It has specific amount of energy, and charges are always discrete in nature. They are not continuous. Let us see. See, you know that charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb. Right? And quantization rule, what it tells? Q equals to plus or minus Ne. Now, see here, N can be 1, 2, 3, 4, 5 and so on. So if I multiply 1 into this, I am going to get what? 1.6 into 10 to the power minus 19 coulomb. If I multiply 2, what I am going to get? 1.6 into 10 to the power minus 19 coulomb. So what will get? 2 into 1.6 will be what? 3.2 into 10 to the power minus 19 coulomb. If I multiply 3, what I am going to get? 1.6 into 10 to the power minus 9 coulomb. I am going to get what? 16 3 is 4. 4.8 into 10 to the power minus 19 coulomb. Yes or no? Now look at this. Initially I am getting 1.6, then 3.2, then 4.8. Do I am getting any continuous form? No. I am getting discrete form. So electric charges are not continuous. They are always formed in discrete and they are always specific. Electric charge or quantized means what? Charges are always specific in nature. Okay. Now if I ask you one question, does a charge of 4.5 into 10 to the power minus 19 coulomb, does it exist? What is your answer? No, not possible. 4.5 does not exist because it is not an integral multiple of 1.6 into 10 to the power minus 19 coulomb. So, but which number is possible? 4.8 definitely I'll get. If I ask 3.1 into 10 to the power minus 19 coulomb, does this charge exist? No, not possible. Okay. So you cannot write any number to show the quantization property of a charge. You have to undergo by this formula only. Have you understood this? Charges are additive in nature. You can either add the charge, you can either remove the charge. The vector sum of all the individual charges will be equal to the sum of the total charge of an isolated system. Electric charges are quantized means what? Charges are specific in nature. They have discrete amount of energy. They have discrete amount of energy. Next property. Electrical charges are unaffected by the velocity, or I would write motion rather. So this is again most important property. What they are telling, electrical charges are unaffected by the motion. Let me compare my charge with a mass. Now you know that mass is also intrinsic property of a matter. You cannot do further research on the mass. The mass itself is the mass, right? So similarly, charge is also fundamental property. You cannot do further research on the charges. So what they are telling is electric charges are unaffected by the motion. So if I take one charge, a minimum smallest possible charge is 1.6 into 10 to the power minus 19 coulomb, and if I take that charge and give him some certain acceleration, so it will move with certain velocity, right? And it is traveling certain distance. But when it completes its journey, what I am going to get in terms of charge? Again same 1.6 into 10 to the power minus 19 coulomb. So you accelerate charge with any extreme high speed or lower speed, there will be no effect or there will be no change in the charge of the body. So whenever you accelerate any charge particle, you will always get the same charge. So electric charges are always unaffected by the motion, irrespective of whatever speed you are dropping that charge. Okay, but it is not the same case with the mass. So see here, according to Einstein's theory of relativity, see, let me tell you, whatever second year physics syllabus you are studying, it is a part of quantum mechanics, okay, or modern physics. Okay, it is not similar to your first year physics, okay, which was a part of a classical mechanics. Okay, it was Newtonian mechanics, and in second year you are going to study Einstein's, or I would say quantum mechanics. So if you remember your first year derivation, there was a derivation for Newton's second law of motion, that F is equal to ma. So if you remember, you had studied that F, force, is directly proportional to change in momentum, is it not? So what you did, F proportional to d mv you did instead of momentum, yes or no? So what you did, you did not differentiate mass, but you differentiate velocity, yes or no? So at the end, rate of change in velocity got you what? Acceleration. So this was a derivation. I hope you remember this, right? Now there was a question you might have not raised to your sir or madam. Why you did not differentiate the mass? Why you only differentiated the velocity? So the answer was simple. The answer was, you told that mass will remain same throughout the motion. But that is according to the classical theory. Quantum theory, what it tells, or Einstein's theory of relativity, the faster you go, the heavier you get. So your mass increases. The faster you go, you will go on becoming very, very heavy. As you go with higher speed, your mass increases. Okay, which is given by this equation, m naught, or m is equal to m naught divided by 1 minus v square divided by c square, where m is relativistic mass, or I would say the increased mass when you are in motion. M naught is the rest mass, v is your velocity, and c is the speed of the light, which is 3 lakh km per second. Now it is quite sure that v cannot be greater than c. No matter what you travel with any extreme speed, you cannot touch the value of speed of the light, yes or no? So let us assume that you go with some very 99% of the speed of the light, but you cannot ever cross the 3 lakh km speed of the light. So when I substitute this value, no matter, this value will be smaller anytime, and when you solve this, c square will be a c square minus this smaller value divided by this value will be less than 0, yes or no? It will be less than 0, and this less than 0 divided by bigger value will be what? It will increase this number, yes or no? You can take any value and substitute here, and you can try it on yourself only. Imagine your mass is 50 kilogram, okay, rest mass, and try to substitute with any value. You will definitely see that this value has enhanced with respect to this value. Okay, so what I am telling you, mass changes when you are in motion, but electric charges will never change when you are in motion. So electric charges are never ever affected during the motion. Okay, take care of that. So irrespective of whatever speed you go, you cannot change the charge of the body. The charge of the body always remains constant. They are never affected by the motion. Now the fourth or the last property you would say, electrical charges are always conserved. Electrical charges are always conserved, just like a law of conservation of momentum, of law of conservation of energy. What it states that you can neither create the energy nor you can destroy the energy, but simply what you are doing, you are converting the energy into various forms. Similarly, same is applicable for our charges also. So what they are telling, electric charges can neither be created nor it can be destroyed, but just the exchange of charges will take place. So nobody can create the charge or nobody will destroy the charge. Only you can transfer a charge from one body to another body. The earlier example of the rod with the silk, that when you rub a rod against the silk, rod is going to lose the electron, whereas the silk cloth is going to gain those electrons. So as a result, what? The loss of the electron by the rod is equal to the gain of the electron by the silk. So what is happening here? The net charge remains same. So plus minus 5 electrons which are lost by rod will be gained by those minus charge by the silk. So what is happening here? Whatever charges you are transferring, there will be no loss in the charges. Only it takes so the net charge of the system always remains conserved. Okay, so electric charges are always conserved. And the fifth property is, already we have studied in introduction, that like charges, we will not discuss more because already we know this. Like charges repel with each other and unlike charges attract each other. Unlike charges attract each other. Okay, so you have to remember this all 4 properties, or I would say 5 properties. What is the first property? Electric charges are additive in nature. Electric charges are quantized. This is the most important thing. Electric charges are unaffected by the motion. Electric charges are always conserved, and like charges will repel and unlike charges attract each other. It's quite easy thing, right? Have you understood this? Okay. Fine. So further, let us see some difference between charge and the mass. So now the picture is quite clear regarding the charges. Okay. So let us find what is the difference, actual difference between the charge and the mass. So I'll make one column in which first column will be for charge and this is for mass. Now can you differentiate the difference between charge and mass? First property, already you have studied properties and you have enough introduction regarding the charge. Now can you tell? You know that electric charge can be positive, it can be negative, or it can be zero also. Like in the case of neutron, where there is no charge, so we may neglect it. Okay, but you know that charge can be either positive or negative. That's true. That is the case with proton and electron. What happens with the mass? Mass can be positive. Yes, definitely mass can be negative. Not possible. Have you seen anybody telling that my weight is minus 50 kilogram, my weight is minus 25 kilogram? No, nobody. So mass will be always positive. You have to remember this. Mass will be always positive. Okay. Next difference. Charges are quantized. charges are quantized. You have seen the quantization property that it has specific values or it has discrete value but not a continuous value. Mass. Quantization of mass is not yet developed. So we are not sure whether the quantization of mass exists or no. The research is going on, but still we aren't sure, or the theory isn't developed yet to study the quantization of mass. Quantization mass is not developed yet. Quantization of mass is not developed yet. Next property. Okay. Can you tell what is the next property? Next property. Can you guess? Or next difference? Electric charge. See, here we are just focusing on the properties only and looking those properties we are trying to differentiate. Electric charge is conserved. Yes or no? Electric charge is conserved. Right? We have seen conservation of the charge, that you can either create the charge nor you can destroy, but it is just transfer of one body to the another body. But what about the mass? Is mass conserved quantity? Are you sure? Mass is not conserved. Remember, mass is not conserved. Mass is not conserved. Now how? See here, mass is not conserved. What do I mean to tell you is, if you know Einstein's mass energy relation, that energy is nothing but what? Mass. According to this is a very famous equation in physics. We tell that E is equal to mc square. So what it is telling, energy is nothing but mass, mass is nothing but energy. So here mass is not conserved because mass can be converted into energy and energy can be again converted back into the mass. So here mass is not conserved. Okay. So mass is not conserved. Next difference, can you tell? Electrical charge between two different charges can be attractive or repulsive. Yes or no? Correct. Electric charge between two different charges can be either attractive or repulsive. Yes or no? Two different charges or two like charges also. Now if I take one electron with another electron, what will be the force of attraction between them? What will be the force? Obviously it will be repulsive force, because two electrons which are like charges, they will always repel with each other. But instead of one electron, I will replace that with one proton. So what will happen? Proton, electron, unlike charges. So here the force becomes attractive. So remember, electric charge between two bodies can be either attractive or repulsive. Depends upon what are those charges. Whether you are taking like charges or whether you are taking unlike charges. If in the case of like charges, they will always undergo repulsion, and in case of unlike charges, they will always go attraction. Next, what about the mass? The mass is governed by which force? Mass is governed by which force? A gravitational force. Is it not? Electric charge is governed by which force? Electrostatic force. Now you know that electrostatic force can be either positive or no, it can be either repulsive or attractive. But what about gravity? The gravity is governed by the mass of the object. So if I throw this pen up, so I am throwing the pen against the gravity. But what is happening? After a few seconds, I am getting the pen back to my hands. Yes or no? So somebody is pulling it, right? So you not the case only with the pen. You take any object, when you throw it upwards, it comes back to you, because the gravitational force is always attractive in nature. Electrical charges can be attractive or can be repulsive, but the gravitational force or mass within the two objects will be always attractive. It will be always attractive. Okay, so I'll write better gravitational force. Okay, yeah, gravitational force force, gravitational force that is governed by the mass. Okay, if you see, I'll write that is governed by the mass is always attractive. So the last difference you can write here, within the charges which force comes into existence, it is electrostatic force. It is electrostatic force. And here which force? Fifth one, what difference you will write? Sorry for no space here. Fifth difference, what you will write? Gravitational force. So now it's quite clear, right? Now you can easily differentiate between charge and mass. Let me recall this once again. Charge can be positive, negative or zero. Mass will be always positive. Both are again scalar quantity, you cannot differentiate that. Charges are quantized, quantization of mass not yet developed. Electric charge is conserved, definitely mass is not conserved because mass gets converted into energy. Electric charge between two charges can be either attractive or repulsive, depends upon whether they are like charges or unlike charges. And here they will be always attractive. Here which force has been governed? Electrostatic force. Here gravitational. Okay, have you understood this? Okay, fine. So now we will study the classification of the substance. Classifications of the substance. So this was the part 1 of your this topic or subtopic, topic 1. So now we are going to study classification of substance. Already you have studied in your school level. Now why we are giving more stress to this topic, electric charges and field? Because it's dealing with electricity, it's dealing with current electricity, yes or no? And you cannot imagine your life without electricity. Now which are the substances that are preferable for electricity and which aren't? That's the important question. So here we are classifying the substance into 3 important categories. Okay, the first one is conductors. Already you know about this, just a brush up. Conductors. The second category is insulators, and the last one is semiconductors, right? Now conductors are those materials which allows the current to flow through it, which allows the current to flow through it. Insulators do not allow the current to flow through it. Semiconductors are those materials whose conductivity lies between that of conductors and insulators. Now let us study one by one. Conductors are those materials which allows the current to flow through it. Now which are these conductors? Now you tell me, you can take an example of this marker pen. Now is this a conductor or is it an insulator or is it a semiconductor? Now you tell me that this is a matter itself, right? And if this is a matter, definitely there should be atoms, and if there are atoms, there should be electrons, protons and neutrons, right? So if electrons are there within this, do you agree it has electrons? Yes. So why I am not preferring this marker for generation of current electricity? Why there are only specific materials like copper, tin, lead, brass, iron, zinc? These all comes under the category of conductors. So do they have some special type of electrons and this fellow doesn't have those electrons? No, the nature of electron is same. The quantization rule says that charge is specific, it is particular, 1.6. They are not differentiating within the charge. But why I prefer copper only? Why I prefer zinc only for the conduction of the current? Because these are called as conductors. If I take iron, zinc, lead, tin, brass, bismuth, these all comes under the category of conductors. So these substances have rich number of free electrons. So earlier I was telling you about the valence electron or free electrons which are present in the outermost orbit of an atom. So if I look at the conductors, these conductors have rich number of free electrons on the surface of the conductor. So I prefer these materials like zinc and all those things. Okay, so conductors are those materials which allows the current to pass through it. Insulators, I don't say that these people don't have electrons. They have electron, but there is more deficiency of free electrons. So here I am giving more stress to the free electrons, and you know what are free electrons? Present in the outermost orbit of an atom. So these insulators do not allow the current to pass through it. So if you want current to pass through it, you need to spend more energy, which is not feasible. Okay, spending 100 rupees and getting a product of 1 rupees makes no sense. So rather this one is much easier. I can give little bit of energy and I can get more output. So which one is preferable? Conductors, which allows the current to pass through easily. Insulators do not allow the current to pass through. What are the example? Rubber, glass, mica, plastic, sand, silicon. These all are insulators from which it is very difficult to pass the current or which allows the current. Semiconductor. What are semiconductors? These are intermediate people. Okay, they are neither conductor, they are neither insulator. Just you can imagine in a classroom, if there are 100 students, some 20% will be in the topper range or in the first class, and some 20% will be in the failure section. Yes or no? But there will be a students within 35 to 75%. So they will be neither clever, they will be neither the failures, but they intermediate between the failures and the toppers. So these kinds of materials are called as semiconductors, whose conductivity lies between that of insulators and conductors. So their conductivity may sometimes lies in conductors and insulator. For that we need to do forward biasing, reverse biasing. It is a part of semiconductors. Okay, forward biasing, reverse biasing, whatever diodes, whatever transistors we have today, it comes under the category of semiconductor. So just remember timing. There is a huge topic that you are going to study in semiconductor, but timing, just understand that semiconductors are those materials whose conductivity lies between that of conductors and insulators. What is the example? Arsenic, okay, antimony, germanium. These all are semiconductors. Okay, fine. So that's it. Okay, we will continue our same lecture in the next class, but please don't forget whatever we have studied today. Okay, what we studied initially, we started with the introduction of our syllabus. Okay, what are the two important categories? Electrostatics and electrodynamics. In electrostatics, first topic is electric charges and fields and electric potential, then alternating semiconductors. And in electrodynamics, current, electricity, moving charges of magnetism and matter, electromagnetic induction, and then optics, ray nature of light and wave nature. And fourth one is modern physics. Modern physics, dual nature of matter, atoms, nuclei, and electromagnetic wave. So that was the brief introduction of your syllabus. Then we came back to the charges. What is charge? It is an intrinsic property of a matter, which is denoted by capital letter Q. Q is given by plus or minus Ne. Charge is a scalar quantity. Like charge will always repel, whereas unlike charges will always attract. Okay, then we have seen the properties of the charges. What are the properties of the charges? First property is electric charge are additive in nature, charges are quantized, charges are conserved. Okay, like charge will repel, unlike will attract, and charges are I think last one property we have left, right? So electric charge are quantized in nature. Then further we have studied the classification of the substance. So three important classification: conductors, semiconductors, and insulators. Okay, fine. Okay, we'll stop there. Thank you.